In this video, we're going to discuss a new concept, which is called a user-defined data type. So far, we have seen a lot of primitive data types, such as integers, characters, double values. They're all coming as pre-built data types, and they're directly understood by the CPU, by the chip built into our hardware. But sometimes it's convenient to design our own data types, which, for example, represent concepts such as date, which may include integer month, integer day, integer year, or, for example, a rectangle object which encapsulates its width and height as a geometrical primitive. So there could be other numerical data types that we can use. And so these are generally referred to as a user-defined data types. So this is right here our handout, and in C programming language, which was invented in the early 1970s, we can start introducing new data types to our programming environment using the struct keyword, which represents the structure. So the structure simply aggregates data members into a single object. So for instance, if we have an array of elements, it aggregates elements of the same type. In case of a structure, it can aggregate together or bring together into a single object different types of data members of this structure. So let's demonstrate this by using this structure rectangle. Now, I already created an empty project with the main file for our demos in this presentation. So I can do something like this. I can just say, okay, I would like to have a new data type. So I can define it as a struct. Struct, of course, is a keyword, and I can give my data type a name. So rectangle. Here, rectangle has two member variables, width and height. And again, they appear to be an integer, but I could also define something like, for example, double area. Okay, so I don't have to be stuck with just one single data type. What I can do is just list whatever variables I think should be good to include in the definition of the rectangle, and I can also use something like standard string object, which will give it a name or some kind of tag which may become visible in some sort of drawing. Okay, so I can add a lot of various types of things to my rectangle and decide that it should have all of these data types. And when the rectangle is instantiated inside the main function, like this main function, so let's copy and paste this for quick demonstration. Okay, and right here we have our main function, which creates the rectangle as a local object. So notice how much similarity here exists with declaring integers. I could declare integer x equals 5. Similarly, now once I have the rectangle structure, now I can just declare it or use it in a declaration of the variable like this, and use the name of the structure as the new data type name. Okay, so this is an object that will be constructed, and of course, if I also want to specify the area, I can do like 20 times 10, something like this, right? And name it backyard. Okay, just really anything. Okay, so this is an example of creation of this new object. Of course, because I'm using string, I need to include standard header that brings string definition. And also we're using cout right here to print the width and height. So we need to include iostream. Now the order of the system includes really doesn't matter. I can do it like this or like this. There's absolutely no requirement in what order you will be including them. It's both, either way is just fine. Okay, so let's find out if this holds all the syntax together, and we can build this. Okay, so this builds fine, and of course it will be printing 20 and 10 for the width and the height. But let me just clarify what happens here. So we discussed many times that when the function is invoked by the operating system, the function, the opening brace right here is responsible for configuring a stack frame, well, like somewhere in the stack memory, a stack frame is created, and in this stack frame area all the local variables and local objects will be placed, and the function already knows how much space it needs over here to accommodate everything that it contains. Compiler basically parses through every line of code and keeps track of like how much space this main function for all of its objects, how much space this function needs in its stack frame, which is the container of all local variables. So this rectangle object, rect right here, is the name of an object, and I will try to draw my object like a 3D, 3D box right here in this memory. Okay, because it's an actual object in memory, and it will contain width, which is an integer. It will contain height, which is another integer. It will contain double area, which is like twice as big as an int, very likely, right? And there's also a string object built into it, which will contain this name when we get it to initialize. So this is what happens when we create this, and so this box gets this name. Right, so this box gets this name rect, and so now once we have it, we can refer to its components, width, height, area, and name, by using the period or dot operator, which is simply a member access operator. So we say, okay, rect gives us access to the object, but it contains individual fields, data fields, 2 integers, 1 double, 1 string, and width of course should give me access to a specific part of that object, and this is why 2 of these statements should be printing a width and height by accessing these 2 data members. We call them member variables or data members of our structures, and you can see that basically the whole idea behind creation of a structure is that we recognize that when we want to create a rectangle, instead of using like 4 different declarations every time we need a rectangle, to instantiate 2 integers, 1 double, and 1 string, we can just declare it as using this user-defined data type named rectangle, and it will instantly contain all of these variables or data members, because creation of this variable will allocate this entire object with all of the fields, and these values using this initializer list will be populated according to the values provided here. Okay, so let's just verify that everything holds together nicely. I already built this program, and so there it prints the 20 and 10, which is the width and the height when we access our object. So rectangle here is an object, and this object is the result of instantiation of the structure rectangle. So this is just a technically correct terminology in terms that that user-defined data types are described first by introducing the structure. The structure itself does not create an object. It only provides a mapping of all the data that such object should contain. So we decide that in our application this is a useful concept, and we'd like to create objects of this type. And once we have the structure declaration in place, we then can use its name to provide the name of an object and create it just as a normal variable, and this is the initializer list